Okay, this video is about a maths method called trial and improvement. So if we're presented with an equation such as this one, x cubed plus 3x equals 41. Now we're used to being presented with equations and given a number of options for solving them. And this one is a different method. It's used to be called trial and error. As the name suggests, it's based on guesswork. And typically in an exam question we're given an equation. We're told that the solution, the value for x, is somewhere between two numbers. For example, in this case, 3 and 4. Somewhere between 3 and 4. It'll also tell us that the answer should be to one decimal place. So here's how I lay out the trial and improvement solution. And so I would recommend you draw a small table. And so we have a column of x values. This will be our where our guesses go. We'll put the working bit there, and also a final column for comments. Now the easiest way to explain it is by way of an example, and so we'll just jump right ahead and start this. So we're looking for a value of x that is between 3 and 4 which satisfies this. We will make a guess. We will substitute that value into our expression here and see if it gives us anything near 41. And hopefully as we go through we'll get closer and closer until we hit on something that's a satisfactorily accurate answer. And so we will start, well, it's between 3 and 4, so why not start at 3.5, exactly halfway between 3 and 4. So this question is all the times I've seen them, they're on calculator based papers, and so there's no worry about having to do anything too complex like this on paper. So you can just go right ahead and get your calculator. So we're putting 3.5 here where we see x, and so we're going to start with 3.5 cubed. Then we're going to add 3 times 3.5. And we get an answer of 53.375. And so we compare that with the answer up top there, and we can see that this is too big. So we will just write in our comments column that our answer is too big, or too large, or too high, whatever you prefer. So this tells us that our guess for x, that figure's too big. And so we already know it's between 3 and 4 and it's lower than 3.5. So it's going to be, 3.1, 3.2, 3.3 or so. So the next one we'll try is 3.3. And by the way, the choice of these guesses here is down to you. So not everyone's will be the same. So I'm going, roughly halfway between 3 and 3.5. So again, we'll do the same. We'll put 3.3 in. 3.3 cubed plus 3 times 3.3. That gives us 45.837. Now again, that's too big. That's too big as well. Okay. So it's lower than that. So we've got to, I'd say, maybe go to 3.1 and just see what that gives us. Is it 3.1? Is that the answer? 3.1 cubed plus 3 times 3.1 gives us 39.091. And it's quite close, but in this case our answer is too small. Too small. Okay, So you can see what's happening now. We've got 3.3 as an answer, which gives us 3.3 for the value of x gives us an answer that's too big. 3.1 is too small a value for x, and so it's somewhere in between. So we're really closing in on it now. So we'll finally just try 3.2 just to see. 3.2 cubed plus 3 times 3.2 gives 42.368, and comparing it to the answer that we want, that we're aiming for, it's again that's slightly too big. Now, if we're saying that 3.1 is too small and 3.2 is too big, we're saying it's somewhere between there. And so of these values on the left, we're looking for 2 consecutive values. Okay, so we want 2 values that are next to each other, and we're going to use them in the next step, the final step. At this point, we could visually check, and it could be that one of these answers is clearly closer to 41 than the other. Remember that the answer is required to be to 1 decimal place, so it's going to be in the form of something like this. In fact, because the value is between 3.1 and 3.2, whatever it is, it's going to be rounded up or rounded down. So one of these is the answer. Now, as I say, it may be obvious looking at these results here that one is clearly closer to the answer we're looking for than the other one, and we could just say, okay, it's definitely this one or this one. So we have here, 42, a little bit too big. 31, that's maybe a little bit further away. So I mean, looking at this, I would guess it would be 3.2. But I don't use that method. I prefer to do this instead. I draw a line, and here I use the smaller of the 2 values and the larger on this side, and I find a halfway point. The exact halfway point between these two is 3.15. Now don't worry that this is going to 2 decimal places. That's temporary. This is just going to lead us to choose which one of these is the best. If I put 3.15 into the calculator, 3.15 cubed plus 3 times 3.15 gives us 40.705. Now, how does that compare? It's slightly too low or too small. That means if this value for x that we've used gives us this result and that result is too low, it means the 3.15 is slightly too big. Sorry, do the way around. It means that the 3.15 is slightly too small. It means that our real value is somewhere along from here somewhere. So maybe, somewhere in this region. But the fact that it's in this region, anywhere in this region, means that when we come to round it to 1 decimal place, it will be closer to 3.2 than it will be to 3.1. So I hope I haven't laboured that too much, but for some people who are not very confident with the ideas surrounding rounding of numbers, then I thought I should just make that absolutely clear. And so our answer is 3.2 to 1 decimal place. So here's another example. This time we have x cubed minus 6x equals 72. Again, we're given a clue about where it is. It's between 4 and 5 on this occasion, and again it's to 1 decimal place. So what did we do? We constructed a table. We had a column for x values, we had our calculation in the center, and then remember we had a comment section, which is where we make a note of whether the answer is anywhere near what we're aiming at, which is this. So between 4 and 5, straight away I'm going to go halfway. This is what I would always do, go halfway first and see what that gives us. So we have 4.5 cubed minus 6 times 4.5, which is 64.125. Now we can see that's clearly too low. So we now know at least it's between 4.5 and 5, so we'll jump up. And at this stage you might be wondering why we would go with one guess above another. Well, we're to make educated guesses, so I would maybe go somewhere halfway between 4.5 and 5, so 4.7 or 4.8. I'll do 4.8 on this occasion. But if you choose to do something else, don't worry. In fact, if you make a slightly uneducated guess, it just means that this list of x values will be longer than is necessary, and it will maybe just take up a minute or two longer, a minute or two of your time. So an educated guess halfway each time, so 4.7 or 4.8. Let's try 4.8. Cubed minus 6 times 4.8 gives us 81.792. That's clearly too high now. So we'll get there, 4.8. Okay, so it's between 4.5 and 4.8. There's only two more values then we really need to check. First one's 4.7 and the other one will be 4.6. Actually, I should encourage you to just pick another number first. I wouldn't normally write another figure there. It's just that I can see ahead how this is going to turn out. But we'll try 4.7 first. Minus 6 times 4.7 gives us 75.623, so a little bit too high still. A little bit too high. And then, yeah, we'll try 4.6. By the way, on your calculator like mine, you may be able to go back a few steps in the calculation and change the numbers. So I could have used the same input from the first entry I did, and just changed the number 4.5 to 4.8 and to 4.7 and so on. But I think it's actually quicker on this calculator anyway to just to retype it. So anyway, 4.6 cubed minus 6 times 4.6 gives us 69.736. So again, slightly too low. But look, remember what last time we were looking for? Two consecutive numbers. Okay, so we've got 4.6 and 4.7. One's too low and one's too high, which means the real answer, of course, is somewhere in the middle of those two. And you know, we said that we could inspect these numbers and see, you know, is the one which is clearly closer to our answer. So we could just straight away say it's one or the other. Well, 75, that's about 3 more than this. 69 is about 3 less than this, so it's not very clear. So we'll go back to using our traditional method, if you like. So remember, we draw this little line, we put our lower number of 4.6 and our higher number of 4.7, the two values wherein lies the answer. So the halfway point, 4.65. I hope you'll agree with that. What does 4.65 give us? Minus 6 times 4.65 gives us now 72.644. That's really close, really close. But remember, it's just too high. Just a little bit too high there. And it means that if our answer is slightly too high, it means the x value we used, 4.65, is slightly too high. That's why it's given us this result. And so if we know this is too high, then we know that the actual value is lower than this, so we'll be travelling this direction, won't we, to some point in between. Again, we don't know, it could be 4.62, 4.63, but remember, it doesn't matter, because if it's in this region, remember, we're going to have to round it down or up so that we get an answer to 1 decimal place. So we simply ask ourselves, just look at it, is this closer to 4.6 or 4.7? It's clearly closer to 4.6, and so 4.6 would be our answer. So I'll try and attach some questions with this video, because this type of thing responds well to just practice. And so if you did, I can promise you, if you do 5, 6, 7 of this type of question, that you will become very confident. And so if you see it appear on an exam paper, you will embrace it rather than panic about it. And so I would encourage you to either use those questions or find some more on the internet and just practice them, and you'll see it makes sense. And so, as I said before, even if the question is sort of hidden away in a functional skills question about some different size suitcases or something crazy like that, when you get down to it, you find out a trial and improvement type of question, you'll be able to just sift through all that and just go back to this method of, remember, going halfway between the numbers where you think it is and halfway again, and eventually you'll end up with 2 numbers next to each other, 1 too low and 1 too high. Stick them on your little line, get your halfway point, see if that gives you a result that's too high or too low. If that result's too high, this one here is too high. Your answer's somewhere to the left of it. If it's to the left, it's closer to 4.6, which is your answer. So, I hope that's been of some help, and I will see you on the next video.